Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from Probability and Statistics 1. And this particular question belongs to paper 9709/53 for the session October-November 24. We are going to solve the last of all questions of this paper, which says find the number of different arrangements of the 9 letters in the word happiness. And whenever we solve any question based on arrangements, we simply apply the concept of permutation. So let's start writing our solution. The number of arrangements equal to, so they have already mentioned that there are 9 letters, so 9 factorial ways they can be arranged, and we just divide the number of arrangements by the number of identical letters. So how many identical letters are there? There are 2 p's as well as 2 s's. So let us divide by 2 factorial for p and another 2 factorial for s's. If we use our calculator for finding the result, 9 factorial over 4 is equal to 90720. 90720. That's all about the simplest of all questions of this paper. Well, then the immediate next question says that find the number of arrangements of the 9 letters in the word happiness in which the first and the last letters are not the same as each other. So here there are 2 possible cases. Let us write down the possible cases. Suppose they have told, look at this, they have told that first and last letter should not be the same letter, and we are changing the concept. We will find the number of arrangements that when the first and last letters are same. So let us write, suppose first one is p, okay, and last one is also p. So 1 2 3 4 5 6 7 8 9. Last one is also p. And the other case is, let the first one be S, 1 2 3 4 5 6 7 8 9, and the final one is also S. Okay, let us write number of arrangements when the first and the first as well as first and last letters are same. Letters are same. Well, we have written that number of arrangements when first and last letters are same. So what will be the number of arrangements? Look at this. If the first letter is P and so is the last one, so how many places are there in between them? 7 places. So the letters in between the first and last letters have 7 factorial ways. Number of arrangements will be 7 factorial ways. So let us write equal to 7 factorial ways. Then among these 7 letters there are 2 s's definitely, so we will have to divide this by 2 factorial ways. Now if the first and last letters are same, I mean s's, then what will happen? It will be exactly as same as the letters P, and first and last letters are P. So exactly both the scenarios are same. If we want to solve it simply, we just multiply by 2. So if we multiply by 2, what is it going to be? It is going to be 7 factorial ways. 7 factorial ways is actually 5040. 5040 ways we can arrange them when the first and last letters are same. Look at this, 2 factorial and 2 are exactly same. So if we dissolve these two, it is simply 7 factorial ways. So 7 factorials equal to 5040. Now let's go back to the question. They have told that in which the first and last letters are not the same, they should not be same, but we have found the number of arrangements when they are same. So it's very simple. From total number of arrangements, if we find this reversal arrangement, then we will get our required number of arrangements. So let us write once again, number of arrangements, number of arrangements when first and last letters, when first and last letters are different. First and last letters, letters are different. So we have already explained that it is just nothing but to subtract from the total number of arrangements. What was the total number of arrangements from the previous solution? We can pick up that total number of arrangements without any restriction was 90,720. So from 90,720, if we just subtract when the first and last letters were same, so 90,720, 90,000 equal to 90,720, from which we are going to subtract 5,040. If we subtract 5,040 from 90,720, it is nothing but 85,680. 85,000 and 680. So this is the total number of arrangements when the letters in the beginning and at the end are not same. So the concept is, we have just change the concept in reversal way. That means they have told us to find the number of arrangements when the first and the last letters are not same. First we have found the number of arrangements when the first and last letters were same. After that we have just subtracted these number of arrangements from the total number of arrangements. Let's move on to question number C. C says, yes, over here C is, find the number of different arrangements of the 9 letters in the word happiness in which the two P's are together and there are exactly 2 letters between the 2 S's. Remember, this is the most complicated and challenging question of this paper. So, little by little, let us solve the question. The first scenario is, suppose this is the first letter is S, and in between them there will be P's. Okay, after that again S, and remaining letters are 4 went away, so 1 2 3 4 5. This is the first scenario when P's are in between S's. So what is the next scenario when P's are outside? 1 2 P's and S 1 2, and there will be the another S, and remaining letters are total 1 2 3 4 5 6 went away and there remains 3. For the first case, let us assume that this is 1 unit. Okay, we don't need to make any change to this. And for the second case, let us consider that this is 1 unit. Well, so let's write when number of arrangements when P's are P's are P's P's are P's are between S's, between S. Okay, so what will be the number of arrangements when P's? And another one, let us write this. Look at this. So P's are in between S's. If we consider this to be one unit, then total how many units are there? So 1, 2, 3, 4, 5, 6. So these five letters can be arranged in 5 factorial ways. Then what about this? This box, this unit can change their position in how many ways? Already it is in first position, then second, third, fourth, fifth, and sixth. So it is going to be 5 factorial ways. The remaining letters can interchange their position. Then the large box, large unit, this unit can change its position in 6 ways. Look at this, already it is in the first position, so second, third, fourth, fifth, sixth. In 6 ways it can change its position. So total number of arrangement is going to be 5 factorial means 126, 120 is a 720. This is the first scenario. Then in the second scenario, the most complicated part of the solution, all of the solutions of this paper. Look, if we want to pick up 2 letters for this position and this position, okay, these 2 position, there are 5 letters remaining. Out of 5 letters we will choose 2. So let us write this in word first. Number of arrangements when p's are not in between s's, not in between s's. Well, let us see what is the scenario here. Well, so if p's are not in between s's, so how many places are there? 2 places. These 2 letters should be selected first. Remember, here is the maximum possibility of getting confused. First of all, we will have to pick up these 2 letters, select these 2 letters from 5 remaining letters. So if we pick up this, if we select these 2 letters from 5, it is going to be, first of all, out of 5 we are choosing 2 letters. Well, then these 2 letters will interchange among themselves. Okay, their position will be interchanged by themselves. Then let us see what are remaining there. There are 3 letters remaining. So for 3 letters there will be 3 factorial ways. Or we can write in another simpler way, and the way is not, let us not write this way. Look, if we form the boxes, what is it going to be? How many boxes are there? 1 unit, 2 unit, and there are 3 units. So total how many letters are there? These 5 letters. These 5 letters can interchange their position. Okay. Or look at this. So total how many ways are there? Look at this. In between these inner letters, these 2 letters, they can interchange their position in 2 factorial ways. Then how many different ways are still remaining? Look at this. Here there are 3. 1, there will be 1, 2 as well as 3 ways. And if here there are 3 ways and here 1, 2, let me change the color. Suppose here 1, here 2, then 3, 4 as well as 5. these 5 factorial ways, now each of the units can, that means all these 3 units can interchange their position. So we can write here 5 factorial ways. 5 factorial ways. Now let us calculate the total amount. It is going 5 choose 3, that means 5 into 4 into 3 factorial, 3 factorial over 2 into 3 factorial. 2 factorial means 2, so 2 into 3 factorial. After that 2 factorial or 2 into 5 factorial means 120. 5 factorial means 120. 5 factorial stands for 120. Let us write 120. Okay, so it is going to be, if 3 factorials cancel each other, then these two can also cancel. So 5 fours are 20 and 12 20s are 24. So it is going to be 2400. 2400 ways. In the second case, 2400 ways the letters can interchange their position. Well, then we will have to write the total number. Hence, total number of arrangement, total number of arrangements. Total number of arrangements, if we add up, first case there were 720 was the number of arrangements, and in the second case it was 2400. Okay, so total 24 plus 7, 3120 ways the letters can be arranged as per the restriction they have mentioned. So as I have told at the beginning, that this is the most complicated solution of this paper. Well, let's move on to the next question. The next question is, the 9 letters in the word happiness are divided at random into a group of 5 and a group of 4. Well, find the probability that both P's are in one group and both S's are in the other group. So let us write the scenario. Suppose P's are in the first group, P's. So we have already chosen P, then there are 3 more letters can be selected. And in the second group, there will be S's, because identical letters cannot be in the same group. So 1, 2, 3, 4. Total 9, okay? So number of selection when S's and P's are in different groups. S's and and P's are in different group. Remember, we are not applying permutation concept because there is no question about arrangements. It's just selection. In any way it can be selected. Different groups. We can write here, look at this. So there are total 9 letters. Out of 9 letters, we have already chosen 2 P's. So there remains 7. Out of 7, we cannot take S's, 2 S's. So out of 7, there remains only 5 letters. From 5, we will have to choose 3. We have chosen 3 letters out of 5. Then in the second case, second group, in the second group, there are 4. Out of 4, already 2 S's have been selected. So there remains only 2. So 2 choose 2. We will choose 2. Then look at this. There is another scenario also. What is it? Is alternative. If we make alternative, look at this. Suppose in the first group of 5 there are S's. Let us write here S. So if it is SS, then 3 more letters are to be selected. And for the second one, for the second case, 2 p's, 2 p's have already been selected. So how many letters are to be selected yet? Only 2 more letters. If we observe carefully, we will find that both the scenarios are exactly same mathematically. Look at this. Here we have chosen 3 letters from 5. In the second case also, as S's have been chosen, P's cannot be taken, so there remains only 5 letters. If 4 goes away, 4 go away. So out of 5 we have chosen 3. Then in the second case, 2 p's are selected out of 4. There remains only 2. So from 2 we are going to select 2. So that means both of the cases are identical. That's why we don't need to write it twice. We just multiply that. It is actually 2 times. Okay. So if it is repeated, we can simply just multiply this. If we multiply this by 2, it is going to be 5 factorial, 5 into 4 into 3 factorial ways, and denominator is 2 into 3 factorial ways. 2 choose 2 means actually 1, so 1 into 2, these 2 can cancel out this another 2. So what is, and this 3 factorial can also be cancelled, so it is nothing but 20. Well, this is the number of selection with restriction. Now without any restrictions, randomly if we form the two groups, so number of selection, number of selections without restrictions, restrictions, without restrictions. What is it going to be if there is no restrictions? Look at this. Without restriction, how many ways we can select them? First of all, there are total 9 members equal to. So out of 9, we will choose first 5 for the first group. And there remains 4. Then from 4, we will choose all 4. 4 choose 4. So what is it going to be? 9 factorial over 9 factorial over 5 factorial as well as 4 factorial. Let us write 9 factorial over 4 factorial as well as 5 factorial into 4 choose 4. It was 4 choose 4 means actually 1. So it is simply, if we divide 9 factorial by 4 factorial and 5 factorial, it is going to be 126. So 126 ways randomly we can form the groups of people. Look, our question told us to find the probability. Look, this is actually probability. So if we find probability, we'll write hence probability is equal to probability is equal to, probability is the number of selection with restriction divided by number of selection without restriction. With restriction there was 20 and without restriction there were 126. So we'll just divide this 20. 20 should be divided by 126. If we divide 20 by 126, it is going to be, let me write it after zooming it out, 20 over 126, 126. If we use our calculator, dividing 20 by 126, it is going to be 0.1587. So if we round it up to 3 significant figures, it is going to be 9. That is what the final answer is. So that's all about the solution to all these three parts of four parts of this question. These are the final two parts, which is very simple and easy. That they have told us to find the groups, probability of the groups in which in one group there will be two p's and in the another group there will be two s's. And very simply we have solved it. And then for finding probability, we just divided the probability with restriction, I mean selection with restriction, divided by selection without any restriction, that means total number of selections. Then we got the probability. Then if I show you the previous page was this, which was also very simple. So among all of this solution, actually the most complicated solution, the twisted solution is this one. Remember, number C. So please be very careful while solving number C. And I tried my level best to explain every tiny part. If it helps you, please pray to Almighty Allah for the betterment and good knowledge for mine. For me, pray to Almighty Allah. Fi amanillah.